for this nice introduction, and we have known each other for a while. So today I will talk a little bit about my second career, I would say beyond GPS, GNSS, and even GLONASS. And I would like to give you some perspectives on what are the challenges to deliver ubiquitous indoor positioning. So this is, let's say, the summary of this presentation here, where indoor positioning has multiple aspects. One about location technology, which needs to be deployed. And here we are, the second one is about beacon information. So here we are putting ourselves more in the context of Wi-Fi or some other infrastructure positioning. We need also map information. And before the last point is infrastructure information update. All this information is aging or is outdated very fast. And last but not the least, what are the business and legal challenges? So about the technology here. So there are definitely some existing technologies which are more closed systems, and which will work for, let's say, a few venues with possibly a good accuracy. But it's usually a problem of scalability, and the carrier and handset manufacturer would like to have a much larger, let's say, scale and of development here. So coverage, there are database and urban Wi-Fi. Still, the accuracy is relatively poor compared to GPS. And when we are looking at a sub 10 meters indoor positioning accuracy, that means that the Wi-Fi access points need to be located within at least this accuracy, and actually probably more like another magnitude better. So the 10 to 20 meters Wi-Fi location, let's say AP location, won't cut it. And again, we need to have a way to fill in the gap. So on the technology and side, the positioning side, so there are definitely GPS which have been around for quite a while, but as everybody knows, it won't cover real indoor coverage. And if you push the envelope, the accuracy will degrade significantly and will be way beyond the sub 10 meter level. So Cell ID has been around, and also by Qualcomm for a long time. So it's very good always on the technology, but still accuracy is not good enough here. So wireless LAN RSSI is one of the, let's say, the most used solution for Wi-Fi in general. Still has some issues about very high sensitivity to environments, and is also, relatively loosely correlated with a distance. So power is not necessarily distance. Okay, and the MEMS, that's what can be used to fill in the gaps between these other technologies which are more infrastructure related. And in this case, MEMS will be able to, let's say, propagate the position between the previous to next point. Okay, and UWB is definitely excellent performance, but issues with the deployment of this technology and very high cost as well. So about the beacon location on or RF fingerprinting. So I am putting both ideas, because some people are using directly beacon location, some of them are using RF fingerprinting, which is kind of the two aspects of the same issue here. So again, the accuracy is very critical, and I know for now 4 possibilities to collect this information. The easy way would be to get it from the venue owners themselves. there is no data collection to be made, I mean, per se, not physical data collection at least. Unfortunately, venue owners have usually a very diffuse or unavailable information. I mean by that if you are in a mall and aside from the infrastructure itself, there are multiple small store owners who have their own AP, and which means that usually this AP location won't be known, and even the MAC address, nothing will be known here. Also, this is not necessarily accurate because the data collection was made probably more for data transmission, not for positioning, and because it's essentially, I mean, a manual operator, let's say, operation. That means there will be some gross mistakes from place to place which need to be detected and corrected. Other solution is war driving, war walking. Okay, issue is of course for locating APs inside indoor. I mean, indoor will be some issues with hearability, so you will get the periphery, nothing inside. Accuracy is not that good, specifically if you are waiting, or let's say depending on GPS in urban environment to do reverse positioning. And there is a tendency, I mean, with at least some of the algorithms to have all the AP more aligned to the road, means that they are absolutely unusable for indoor positioning. So you can do also a systematic survey, very high cost. Ground reference is an issue. Okay, yes, you can start it from outside with GPS, but still you need to know where you collect the data, and the turnaround time is quite large, so scalability is not there. So now there is a last promising solution, crowdsourcing, so where normally the coverage would be as large as where the user go. Conceptually, the update will be very fast, and the growth of the database will be very fast, but legal aspects means that we need to have the authorization, the legal authorization of the user to collect this information. Still the ground reference, so you need to know where these data were collected. Also, there are some issues with the mobile measurement engine. I mean, in order to get a very good quality, you need to have a fast rate on the measurements, and not all the mobiles can do that today. And finally, you need a serious probably cloud infrastructure to collect all this information in a single point and to do real crowdsourcing. All this information will come from multiple sources, of course. So next challenge is about map information. So it doesn't help too much if you don't have maps of the area. You need to put the blue dots somewhere. And I mean, from the multiple sources of map we have today, one of the issues is geometric exactitude. Means that the general dimension should be correct. This map should not be stretched or, let's say, I mean, deformed in some way. So in this case, if you are using a geometric positioning technique, it won't work too well. Also, because some people might, or some app developer might want to use their own map, you need georeferencing. So you want to provide the position in some kind of lat longe, even if it's indoor. Also, for it to be very useful, you need a lot of information, richness of information. Let's say having just a rectangle in a mall where there is this anchor store won't get too much, won't help much. Information hierarchy as well. There are different level of persistence in the information. I think it's clear that if you are looking at the walls, they won't change very often. If you are looking at the store brand name, they might change a little bit faster. And if you are interested by the shelves location inside the store, they will change much faster, maybe at the 6-month level. And now if you really want to go to the item on the shelf, might be every week. So there are multiple levels of hierarchy, and they could not be combined in a single map. They have to be dealt with separately. And of course, has to be timely update, otherwise this information is absolutely hopeless. Issues are multiple sources, very fragmented sources, and no standardized format. So the standardization will be a major issue. And also quite large variances in quality. What I mean by that is it's very easy to get a map from, let's say, some kind of a raster image, like a JPEG or some kind of imaging. It will be more difficult to get a vectorized information where you will have much more accurate information. So problem is, depending on the quality of the raster image, the pixel has a value as a size. You cannot go below here. And this is much more difficult to process rather than vectorize if you want to do some scalable deployment. So on the infrastructure information update, I think that's one of the things the most important in my mind. It's nice to collect this information, but if it's not updated very regularly, it doesn't have much value. So practically it looks like the map and the beacon information is outdated about after 6 months. We are not talking about a shelf location, anything like that, which is the second line, I mean, about very fast turnaround time on the shelf assignment for the items. Also, there is no real single owner, so multiple people will have to be contacted to get this information and might not have the information in the format you want. And if this information is not updated enough, it doesn't have much value. I mean, the user will say, okay, this is wrong, I have the wrong store name, so I'm not interested in this technology anymore. And for the venue owner, of course, if the user loses interest, the venue owner might lose also interest in general. So about the solutions, so the most, the one which would come to the mind initially, it's interconnection of databases. So that might work for the shelf and the item location, but database is probably even more fragmented domain. So that's probably not too good. Periodic surveying, that definitely would work, but the cost will be multiplied by the number of surveys, and I don't think it's practical here. Probably one of the most promising one would be the crowdsourcing. So now I'm making the distinction between active or passive. Active would mean that somebody downloads some application and does the data collection, consciously. Passive is that the user moving around collecting data will provide, of course, with their authorization, will provide this information, which over time will be used to improve the AP location, maybe, also to discover new APs and that kind of things here. But I think that this subject is quite open at that point. So about the business and legal challenges here. So on the business side, we definitely believe that there is a need for an ecosystem. It's a very complex problem. So now, problem is, should the venue being enabled without mobile being enabled, or should the mobile being enabled without venue, or vice versa? So that's typical catch-22 issues. And if both are not enabled simultaneously, the interest will go down significantly. Okay, also this solution needs to work on multiple OS, HLOS, and also should coexist with existing solutions as well, which are at the application layer. So it's not necessarily the only solution application layer. There are multiple things which can be done below the application, which would give more performance and more capabilities. On the application developers, they really want simplified APIs. They don't want to relearn everything, and they would like to have the GPS in mind here. They would like something very close. And I would like also to use any map. I mean, claim to fame is usually having a map with different colors, different style, so they don't want to use a standard map as everybody else. And the scale is also another issue, going back to the ecosystem. If there are not enough mobile in venues, there won't be enough applications as well. Also on the venue themselves, so usually the venues have been developed, or the infrastructure has been put in place for optimal data coverage, not optimum position accuracy. So which is a difference, significant difference, and there is a reluctance from the venue owners to invest in more infrastructure until all the three first points are already covered here. So definitely we are going back to the sharing the information and to the standardization issue as well. On the kind of legal side, as also, let's say, technical side, there is still this GNSS perception that the indoor positioning should work as well as GNSS, and this might become an issue, legal issue, specifically if at some point the operators or the government wants to mandate indoor location as an E911 equivalent requirement. So monetization is another issue here. There are so many players in this ecosystem that the whole, let's say, monetization chain is not ready yet. And to close with that, privacy, it's clear that users would prefer usually not to show their location, or at least would like to have a control of this location here. And privacy, there is also the other side on the venue owner, which is that the venue owners want to have the control of their data, and they want to be able to, for example, have them erased from mobiles at some point, so maybe a time base or something like that. So on the conclusions, we believe that indoor location will happen much quicker than outdoor location here, just because there is this existing experience of users on GNSS in general, and location ubiquity is the normal, let's say, outcome and expectation after that. So, so there will be quite new entrants here, and I think we'll see more and more small companies trying to grab this thing. So also the value will be from the application themselves, way beyond the blue dot experience, and the usage of this navigation information will make the difference here. So we also believe that using existing infrastructure and existing mobile technology would accelerate the rapid market launches here. So we see also that all these challenges will slow adoption, and they would need to be addressed by the community, including the standardization phase. On the solution itself, and the universal solution is a must. We don't think that any user will want to change their mobile or to buy anything else. They will want this technology to be available on any mobile, any operating system here, and that's a serious challenge. So standardization, again, that's, we believe, the right direction. Will be for maps, which is definitely the building block, but all other information like AP or something like that will be the same here. So we believe that ecosystem and partnerships in general will be a viable solution here.